Welcome, everyone. My name is Jerry Lee, the life science specialist from ARC. So today, the workshop is about building a reproducible workflow with Apptainer. The workshop will have two parts. Today and tomorrow, both have 1 hour from 1 p.m. to 2 p.m. And both of the two parts will be recorded. And once the recording are available, we will email everybody. So you can check them in our YouTube channel. Before we start, we would like to acknowledge that the University of British Columbia, both campuses are located on traditional, ancestral, and unceded territory of Musqueam people and Silex people. So today we will be talking about what the container is and what an Apptainer container is, and how people can benefit from the Apptainer container for their research, especially when using high performance computing. And we will show some examples of using pre-built Apptainer containers and the software inside it. Tomorrow we will talk about how to make a custom Apptainer container. So if you are familiar with Apptainer container and you are familiar with how to like pull or create or using a pre-built container, feel free to drop off and join us tomorrow. But basically today we will cover the first 3 questions, and tomorrow we will focus on the last one. So most of the so you can find the useful links in this slide, and if you don't have the slide ready, you can find the slide in our TOD at arc.ubc.ca/docs, and you can log in with your CWL authentication. Find another one. It's the browser issue. Hope I'm not fired from UBC. Okay, so if you go to our TOD and scroll down and find the training sessions, and the first one will be the Apptainer workshop. So you can find the slide for today and tomorrow. The date is also listed here. Okay, let me go back to. Okay, I also listed a few other links, like this is the homepage of Apptainer and the documentation of Apptainer and the GitHub site, and also the Singularity Hub and Docker Hub. I will talk about this later if you are not familiar with these 2 sites. But if you want to find some links, then they are all listed here. Okay, so so when you use HPC, high performance computing, the main issue you are facing is that you are not the system admin. So if you want to install a program, if you want to change some configurations of installed program, then you don't have the permission to do that because you're just a user. And sometimes when you, of course, many programs can be installed without sudo privilege. You still can use it, install it in your local directory. But sometimes some tool may require you install specific versions of dependencies that the system doesn't have. Then you still need to like require the installation still requires you to have the root access. And in many programs, they have pretty great documentation, and you can find the guide of installation in their GitHub site or other official website. But to install it, you may find some these commands like yum install or apt get install. But again, these commands need to be done by need to be done with root access. Basically, you have to be the system admin. But as an HPC user, you are not an administrator, so you don't have the permissions. And another pain point is that it's difficult to share tools because everyone in high performance computing is the kind of a semi-separated user. You do have some workspace to share, but when you try to install programs, it's really hard to share your pipelines, your software with others. And when you install the program, it's very hard to control the versions because you are not the system admin again. So the main point is that you don't have the root access. Okay, so that's why Apptainer is designed or developed. So Apptainer is previously called Singularity. Maybe some of you are familiar with that term. So Apptainer is very similar with Singularity. It's just an upgraded level, upgraded version of Singularity. So it's designed for high performance computing. So basically it's working in Linux operating system. So if you have a Windows laptop or MacBook, then you may find you cannot install Apptainer in your laptop because it's using a Linux system. And it assumes you don't have root access when using it. It's different from Docker, like another or like a more popular container. And it's easy to share and reproduce because once you build your container, it's the versions, the files are all frozen. People cannot touch it. And the last advantage is that it's independent of the host environment. So some server uses Ubuntu, some uses CentOS. So it doesn't matter which operating system or which Linux distribution your server use or your laptop use. The Apptainer container can work independently. So that's the beauty. Okay, so a container, to introduce the concept of the container, we may need to take a look a little bit the structure of the operating system. So basically, when you have either a laptop or desktop or high performance computing, you are dealing with some hardwares like the CPUs, GPUs, so these are called infrastructure or hardwares. And then you have the host operating system built. Sorry. Host operating system built in this infrastructure, and then you will have the container in the outer layer to work with. So it's basically a package of code dependencies and the libraries necessary to run the software. You can treat it as a mini operating system. There are two types of containers. One is called Docker and the other is Apptainer. So Docker is more popular. It's used in Mac, used in Linux, used in Windows, all kinds of operating system, but it's not. It's more like the Microsoft OneDrive. You actually mount the Docker container into some some places or some directories in your computer, and it's not a single file. It's a collection of files and folders. And if you want to use Docker Hub and to share with other people, you actually connect to the internet, and your Docker image in your local computer is connected to the Docker Hub in real time. So it's not very safe. And the Apptainer is actually designed using the idea of Docker, but it's more specific to high performance computing. You can generate a single file in this with this extension file name .sif, which represents singularity image format. So singularity is the previous name of Apptainer, but it still uses this extension file name. So this is a single file. Everything like your tools, your configurations, your files, and your folders are all stored in this single file, and nobody can touch it before you open it. So it's easy to share, and it's also more secure. So like going back to the operating system and the relationship between the container and the operating system and the hardware. So this diagram shows the interactions among these three. So so first we have CPU, GPU, RAM, and hard drive, and these are hardwares. And then the operating system basically will have like two major layers. One is called kernel space, which talks to the hardware directly. And then based on the kernel space, we will have this user space, which has, for example, the library, the compilers, some programs that you use like MySQL, Python. So these basically are the components of operating system. But for a container, you can see it doesn't have the kernel space. So you still uses the kernel space, but it has some of the user space, like Python, like the compiler, GCC, like the bash, like libraries, but it doesn't have all of them. It only has those components that are necessary for you, for your software. For example, if I want to use Python 3.9, which requires maybe some libraries, then it only has that libraries needed for Python 3.9. It doesn't have all of the libraries with like same with the system. It only has part of them. Maybe the versions are different, but it's just it doesn't have like it's not a comprehensive list of the package or libraries. So that means you can even use different Linux distribution because the kernel is the same. It's still the Linux kernel. And for example, the hosting server is using CentOS, and in your container, you can use Ubuntu, you can use Red Hat, you can use any type of Linux distribution. So I talked about this before, but basically it's previously it's called Singularity, and now it's called Apptainer. They upgraded a bunch of functions. The main upgrading to us as a user is that before you need a Linux machine with root access to edit the container, but now you can do it in Sockeye or in Cedar, even you are not the system admin. So that means you can install program in Sockeye, basically install any program in Sockeye or Cedar. Okay, so is there any questions so far? That's good. Okay, so for today we will be talking about the pre-built Apptainer. So we will not touch the container. We just use it. So first, grab. Okay, so now I'm in Sockeye. Let's build. Okay, now the this folder is empty. So if you want to build a container, you can do module load Apptainer / with the version, and now you can use Apptainer from Docker. So although it's Apptainer, it's not Docker, but it still can use the Docker Hub to get the container from it. So there are millions of pre-built containers for you. Many of them are quite useful. For Singularity container and Apptainer, so the main difference, I think, is that with Singularity, if you want to edit a container, or for example, install a program inside a container, you have to prepare a machine which runs in Linux operating system. And you have the full control of that machine. So for example, your laptop, your desktop, you need to have the sudo access. You need to be the system admin. Otherwise, you cannot edit the container. So for example, if I'm pulling down an Apptainer Singularity or Apptainer container from a Docker Hub, let me run this first. And it starts to build, and then it will generate a new file in this folder. The previous is empty. Now we have a new file, ubuntu_latest.cef. So if you want to, so this Ubuntu, you can see the file size is, sorry. The file size is only 29 megabytes. So if you want, that means it's a very minor version, a light version of Ubuntu. If you want to, it misses a lot of programs. You don't have vim, you don't have wget. If you want to install it inside this CIF file, if you are using Singularity, you need to do it in a Linux machine, and you must have the root access of it. But with Apptainer, you don't need that. You still need to run it in Linux, but you don't need the root access. Does that mean you still build a container with Dockerfile and store it? We build it from Docker Hub, but we don't store it in Docker Hub. If you want to, you mean if you want to convert a Docker to a Singularity container or Apptainer container? Yes, it's coming from Docker Hub. That's why it's very convenient. So yeah. Yeah, we poured down the container from the Docker and convert it to Apptainer format. You don't lose anything. You keep everything inside. So that's how you build the container. So as you can see, the command I run is apptainer pour docker colon // Ubuntu. So this means this apptainer container is pulled down from this website. And this website is the first one listed in the slide, which I use the broad font to highlight. So it's called Docker Hub. And if you copy and paste, you don't need to log in. You just want search the software you want. For example, I want to find bioconductor. This is very useful R package manager for bioinformatics. So you can see the updated date is 4 days ago, and it's the kind of official it's by bioconductor people, so it's a official container. Yeah. So and if you want to use this container, which has the bioconductor you want, you just need to convert this command. So if you are using Docker, you need to run docker pour bioconductor / bioconductor underscore Docker. But if you are using Apptainer for high performance computing, you can just copy, paste, and then delete Docker because we are using Apptainer. Then pour is the same, but before bioconductor, add docker colon // Then that's it. Okay. And so after you run this command, you will see a new file called bioconductor docker underscore latest.cif. So you can see it's converting to SIF format, which represents for singularity image format. It may take some time. Let me go back to the slide.
Does this also work for private repos?
Sorry, can you see it again? Your volume is pretty small.
Does this work for private repos?
Can you hear that, Jeff?
No, I can't make it out.
Yeah, it's the volume is pretty low. Could you type it? Does this work for private repos? I didn't try, so I don't know the answer. I didn't try to like upload the image into the repos. So you don't need to log in for Apptainer, but if you are asking whether you can like, for example, convert your Docker image to Apptainer, I know there's a bunch of way, but if you can upload it to the yeah, if you can upload it to your private repo, and then you can pour down from your private repo to generate a singular Apptainer container. But I didn't try, so there are a bunch of ways to convert it locally. Yeah, I think it should work, as Jeff said. I think so. If it's private and if you have a local repo, then a private repo, you only the owner can do it. But yeah, again, I didn't try. I don't know whether it can work with a private one because I only tried the public container. Maybe I can find some. I know you must. There are a bunch of ways to convert your local Docker image to Apptainer container image. But I need to find. I do some research before answering the question. Okay, so now it's done. So you can see there's a new container generated, which is much bigger because it has lots of R packages installed. So bioconductor underscore docker underscore latest dot sif. So that's the main way. And the other resources we can use is Singularity Hub. It's the same, similar with Docker Hub. You just go to the website and search for the package you want. Since it's the program has already been upgraded to Apptainer, and this website is kind of inactive now. It's a read only. It's not maintained. So the tools inside and the containers in this website is all kind of out of date. We still recommend people to go to Docker Hub to find the container image. And the last resource you can get the container image is some it's the developer of some big developers like NVIDIA. They will prepare some image files or for you to pull down, but it's not very commonly used. So another question. So that. Okay. So okay, once we have this container, to use it, there are two common ways. One is we have this two container. If I want to use the program inside, for example, Ubuntu Ceph, then I can do Apptainer shell Ubuntu Ceph. So now you can see the this changes to Apptainer, which means I'm inside the container. So if I want to see where I am, let me see. So this file LL doesn't work because this is not installed. And if I do vim test.txt, and you can see the command not found because in this container it's not installed. If I want to check the per version, so 5.35. If I want to check the Python version, Python is not installed. Python 3. Okay, Python 2. Both are not installed. So again, this is a very light version of Ubuntu. This may not be used for many people because basically it doesn't have any useful tools. But in the Docker Hub, it has some containers pre-built with very useful tools. For example, the bioconductor is very useful for bioinformaticians. Another way to run the container. So if you want to quit, then just type exit. Another way to run the Apptainer is instead of shell, you do exec, which represents execute. Then the container file name, then the program name, and then the flag, the option. So it will tell you that it will run the program. So if you have a Perl script, then you can just have my script. For example, if it's called my script.perl, then you can just run it like this. Okay, so that's for Ubuntu.sif. Now, I also download the bioconductor Docker. It has more tools installed, so maybe we can take a look. So again, Apptainer, shell bioconductor. Again, I'm now in the Apptainer container, and because it's an R package, so let's see how many packages are installed in this program, in this container. I just copy this, which can list all of the packages and the versions. You can see lots of R packages are installed, like DevTools. Yeah, so some container is big, is huge, but it has lots of useful stuff. So if you want to run this script outside the container in a single command, you just need to, for example, write all of the R script. Prepare R script. Now we have the R script here. And what we need to do is just do Apptainer execute conductor and R script. R script test R. It will list all of the R packages. Okay. So if you are running Python, then just prepare a Python script and run Python there. Okay, so in Cedar, you may find this command doesn't work. That's because so now I'm in Sockeye, so this command work. It's because, but in Cedar, the host is using Linux operating system. The container is also using Linux operating systems, although they are different, using different distributions. But some folders structures are the same, like /etc/user/lib. So they are the same. So the host has these folders like user, lib, home, directory, and project scratch space. And in the image file, of course, it doesn't have project and scratch. That these two are unique to high performance computing. But it has etc, user, lib. So in what you see when you use container, you are using the container, the etc inside the image, inside the container. You're using the user inside the container. You are not using the user in the host. You are using the /lib inside the container. But when you are using home, you are using the home in the host, because in default, the home directory is mounted into the is mounted when you use the container. So, but the project and scratch space in Cedar is not mounted. So that's why you cannot find the file. When you use it, you have to mount them. So the way you mount them is add this flag -b project. So just run. When you run this, after execute on -b or -- bind, they're the same. And project space. Of course, here is the same because the project space in Sockeye is automatically mounted. But in Cedar or some other high-performance computing or some other servers, you may want to check whether this is mounted. The way you can check is pretty simple. So if you do Apptainer share and then df, so you can see the file system. If you are familiar with Linux command, then you probably are familiar with this command too. So you can see the /project, /arc project, /arc home, R, and here /scratch are mounted automatically. But in Cedar, if you Apptainer share to any zip file, you won't see these two. So that means you have to use -b, uppercase P, to mount them. Okay, so if you want to use the GPU, if your container has the GPU, you just need to remember you need to add this --mv, otherwise you won't be able to use the GPU resources. So it's not, you can find the information in this slide. I'm not going to show the examples. So for, but sometimes now we have two containers. One is this very light version of Ubuntu, which is not quite useful. In most of the cases, we're going to use some big container image like this one, bioconductor. It installed, like it has lots of R packages installed, but most likely it doesn't have the one you want to use. For example, it doesn't have ggplot2. If I share into this bioconductor container and then go open R interface, and then check if I want to use this one, it will tell me that there's no package called ggplot2 because it's not installed there. So what we can do now is to install it, but you can install it either outside of the container or inside the container. So today we will, I will show you how to install it outside the container. Tomorrow, we will talk about how to install it inside the container. Okay. So to install it, what we need to do is first we need to go back to the system, the Sockeye system. And now we are in directory in my project space. And we need to make a new folder like rlib. And I'm going to install the R package in this folder. So what we need to do is then go back to the container, so Apptainer share, and open R, and then change the library path. So now it's the default one. Both of them are inside the container. Of course, we cannot use it because the zip file is not touchable, it's not editable. you will receive error message if you just install it. So what we can do is copy this directory, followed by the alias we just created. We check, we have 3 directories now. The first one, the highest priority will be our new folder, which is located in Arc, in Sockeye. So it's not inside the container; it's outside the container. It's actually in the same folder of the container. And then if I do install package, then it will install everything into this folder, which is located outside the container. So that's how you install some packages like Python, like R packages with a pre-built container without like editing it. It's convenient, it's pretty fast, but sometimes it's the downside is that sometimes it won't work because the container may not have the prerequisites for the packages or for the tools you want. You need to install some libraries. You need to install some other tools which is needed for the new package. Okay, so now if I do now, I can load ggplot too. Okay. Oh. If I quit, if I log in again, and ggplot2, you see there's no package for ggplot because every time when you try to log in, you have to repeat this command. You have to do it again. Because the zip file doesn't remember this R library path, and it's not touchable, it's not editable. So you have to do this again. And after you do that, then you can find the R package you installed. Okay, so if you want to write it into a script, then remember, put it this dot, define the new library path in the beginning. Otherwise, it won't be able to find the package you installed. And same thing here for Python package. You can just change the system file path by this command and then install it. Okay, so that's all for today. Is there any questions? Go back to page 17 and 18. It's the system's home. So sorry. So I'm now in the container, right? So I'm now in the container, and if I do df-h, you can see the home is /arc/home, which is, so if you go to home and pwd, you can see it's the home directory in Sockeye. It's not the home directory in the container. It depends on how the system admin set when they install Apptainer. So if I quit and type which Apptainer, so you see we call this Apptainer program from here. And if I go to this directory and go to the library. Apptainer. There should be a configuration file. I don't have the right permission, but I still can use the them. So let's say project. You can see. So this is how it sets to bind. Just ignore all of the dark blue. You don't need to see them. You just see this bind path equals to etc local bind path equal to hosts. These two are in default, but our system admins add these five rows. Bind our software spec so that which allow you to use the software in Sockeye, and bind to home directory, which allow you to make your home directory consistent inside and outside of the container. So your home directory is always the home directory in the in Sockeye, in the host, not inside the container, because inside the container, the home directory will be sometimes /root, sometimes /home, could be confusing. And it also mounts the project and also the scratch space. So it totally depends on how this configuration file is set up. In Cedar, you only have these two lines and the home. So that's why you have to use ~B to mount the project space and a scratch space. Otherwise, your files in these two spaces will not be able to be found by the Apptainer container. Does that answer your question? Maybe because you can open the there's a $home variable. You can think in that way. So yes, all of the Linux distribution should have a $home variable, which has a home directory. And if you install just like if you install a Windows, you will have a C drive, have a user folder in C drive, and in Mac or Linux system, you will have a /home, which has the username under this folder. Like for example, my name is Jerry. If I have a Linux laptop, then if I install Ubuntu, I will have a /home/Jerry, because when you install the operating system, you set up your account, right? You set up your username, your password, and I will put Jerry as a username, and then when I do that, the Linux system will create a folder called Jerry /home, and that will be my home directory. And because the Apptainer container is a mini operating system, you can treat it like that. And when you create the container, it will have the similar step, like creating a user for it. And that user will be the user will have a home directory. So if I do so this is in Cedar. Oops. You can see the mount. You can see the bind path is only these 2 lines. There's no project space in Cedar. So if your file is located in project or scratch space, you have to use -B, uppercase B, to mount your project space. Otherwise, the Apptainer software cannot find the file. Yeah, that's how people said it. How the guy who installed Apptainer in the system set up the program. Is any other questions? Okay, so if you have any questions later, you feel free to email me, and my email, you can find my email in the slides, or I just put it in the chat box. So tomorrow we will have a more advanced contents, which is to edit the container, put things inside the container. So see you guys tomorrow. Enjoy the afternoon.